Hey everybody, this is Larry. This is February 9th of the Leetcode, or Larry just doing an extra question. Yeah, because the other one was done before, so let's just pick a random question. Let's keep it medium, and I think I could choose. Someone told me that I could choose a premium one, right? How do I choose a premium one? Okay, there you go. Because I keep on picking problems that it was done before, or something like this, or like that I end up doing later. So I'll do a premium, medium, and let's see. Should be a little bit easier. Still get an SQL question. Okay, let's try again. Okay, 1011 capacity to ship packages within D days. Uh, let's do this. A conveyor belt has packages that must be shipped from one port to each other. Okay. The IVE package has a rate of weights of I each day. We load the ship with packages on the conveyor belt in the order given by weights. We may not load more weight than the maximum weight capacity of the ship. Okay. What is the weight capacity of the ship? Oh, that's what we're trying to figure out. Return the least weight capacity of the ship. That way we solve all the packages on the conveyor belt being shipped within days. Okay. So basically we have 15 and you have to do it in order, right? Okay, in order. So this is a I think the first thing to think about is that you have this minimization problem where okay, so you have a let's try a big capacitor, right? Like mentally, let's say we have a capacity of 200, then you can ship everything in one day, and then now, okay, can you go lower? Well, this is where you kind of get this intuition about. Also, this isn't a premium question, is it? Huh? So I think I messed up there again anyway somehow. Oh well, I mean I already am solving it, so I'm going to finish solving it. But I just realized that, even though I said I wanted a premium question, silly Leetcode. But in any case, yeah. So let's say we have a smaller number, and you know that if something works for 200, then 201 will be fewer days, right? And but it may also mean that 199 may not be enough days, or it'll be more days, but maybe not be 5 days. So this is basically what this intuition of like getting a number and then trying the answer is the basis for binary search. And of course, in this case, or in order for it to be binary searchable, you have to have some function that you test every time, and that test has to be fast enough, which is usually roughly linear time, but you can also have constant time tests and log n tests, and maybe even n squared, depending on if n is depending on how big n is, right? So based on that, we know that we have a linear thing because we just have to go from left to right, because we just have to go, we cannot change the order. So there you go. Yeah, so let's start. So left is equal to 0. Oops. Right is equal to 500 is the most times this, so it's going to be like 500 times 5 times 10 to the 4th or something, right? It's the most, maybe plus a little bit more, so let's just make it 6. I don't know, right? And then this is the this is just regular binary search stuff. And then okay, if mid is good, that means that what is good here, right? Good means that we ship within the number of days. If this is good, then that means that we want to try a smaller ship capacity, but mid is good. Otherwise, this is not good, and we need to try a bigger capacity. That's basically the idea behind binary search. And of course, now we have to implement the good function. I call it target, but yeah, and this is going to be the target rate. So basically, we could just count. Yeah, so I actually want to make capacity at least 1, just because I don't think 0 would ever make sense. I mean, it doesn't make sense even if the constraints kind of, but it will give you a weird thing if you are not careful. And I probably have done it in the past. But yeah, so basically now capacity is equal to the target, and then maybe days is equal to, used, or days used, or something like this. Days used is equal to 0. So then now for x in weights, we go, okay, so capacity, if x is greater than capacity, then capacity is equal to target and days used, right? Increment by 1, else capacity minus x. And there's a caveat here, which is that if x is greater than if x is greater than target, then this is still going to be true, right? So, well, you could maybe write another way, which is that if x is greater than capacity, then we return false, right? Because that means that this is just not enough. Otherwise, we return days used is less than or equal to days. I think this should be good unless I messed up a sign or something. But okay. Did I mess something up? All right. So one thing that you can use to debug is just print out target and the days used. I think that should be good. Oh. Yeah, okay. No, that should be okay. So 15 would take 2 days. So this should return true. So then that you would try to get a smaller number. I guess that the logic is right, but why is that? Did I mess up this code? If x is greater than target, then days was used as plus 1. If it's still bigger than capacity, oh, I'm dumb. This should be this, and then capacity, I guess minus x again. Okay, yeah, okay. Still wrong though. What do I return? I return 11. Because basically, this starts with 1 day used. Okay. So, okay, I mean, as you can see, it is very sensitive to, you have to be really correct on this function. Because if you're just off by 1 somewhere, like I just forgot that obviously you need at least the first day to fill it up. If you don't, I mean, it was just wrong, right? The code is wrong, you get a wrong answer. So, yeah. All right, let's give it a submit. But this is why you test and debug. Yeah, so what is complexity here? Well, this is linear time, constant space, as we talked about. This is going to take log of O of log R, where R is the range, times N, right? Where R is the range, and O of log R space. No, just O of 1 space, I suppose, right? Yeah, that's all I have for this one. Let me know what you think. Yeah. This kind of concept about binary searching on the answer is just about having a feel for things, and I think I've gotten a question in the past about on the Discord about how to figure out if this is binary searchable. The answer is I don't really quite know per se, or rather like I don't look at a problem and go, oh, this is binary search necessarily. But sometimes I will be like, okay, is this binary searchable? So maybe I have a checklist mentally, maybe of like, oh, is it binary searchable? And then I go, okay, assuming that this function is binary searchable, then it's fast enough, right? Do I have an O of n function like I have here, or depending on what the n is, maybe n squared or something like this, right? And if I do, then I ask myself, well, is it a binary searchable function? And if those criteria are met, then then I give it a go. I'm not always right, but that's one of the things that we explore. But yeah, that's all I have for this one. Let me know what you think. Yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.